This next one is a classic exam trap, so let's slow down and get it right. Effect modification versus confounding. They can look similar in your data, and they mean completely opposite things. Start with what effect modification actually is. Effect modification, also called interaction, means the effect of your exposure genuinely differs depending on which subgroup you're in. Look at the example on the slide. In young animals, the vaccine gives you a risk ratio of 0.15. That's a spectacular protective effect. In the immunocompromised group, the risk ratio is 0.97, essentially nothing. Same vaccine, same study, wildly different answers depending on who you're looking at. When your risk ratio differs by stratum, that's effect modification. And here's the single most important thing I can tell you about it. Effect modification is a finding, not a bias. It is not an error to be scrubbed out of your data. It's real biology telling you something true about the world. So the two rules are simple. Do not adjust it away. Do report your stratum-specific estimates separately. That's the whole distinction, really. Confounding distorts your true estimate. It creates an association that isn't there or hides one that is. It's a nuisance, so adjust for it and you report one clean pooled number. Effect modification reveals that your exposure genuinely works differently in different subgroups. It's meaningful, so you report each stratum on its own. Now, look at the danger box, because this is where it stops being academic. If you average across an effect modifier, you get a pooled risk ratio that is true for absolutely no one. Take your example. Averaging 0.15 and 0.97 gives you some middling number that misrepresents both groups. You'd overstate protection for the immunocompromised patients who need accurate information most, and understate it for the young animals. That's not just statistically sloppy, that's clinically harmful. The flip side is the exciting part. Effect modifiers tell you who benefits from an exposure. That's the entire engine behind precision medicine and targeted interventions. Instead of a one-size-fits-all recommendation, you can say, this protocol works beautifully in this population, and we need a different approach for that one. For testing, no two names. The Breslow Day test checks whether your odds ratios are homogeneous across strata. The likelihood ratio test for interaction compares a model with an interaction term to one without. And one last subtlety that examiners love, scale matters. Effect modification on the additive scale is not the same as effect modification on the multiplicative scale. You can have it on one and not the other. So whenever you report interaction, always specify which scale you're talking about. Like, subscribe, and share for more.